my title slide moving forward to the next slide. Okay, so this is a hilarious scene from Monty Python, The Quest for the Holy Grail. Looks like it has some plastic on it. I heard we were playing a drinking game. So it seems like it's already been played a few times.
This is Burn the Witch. Is that what
yes, this is the witch burn. So I have a very complicated agenda, so I'll leave it up during the talk. But I'm going to talk about, first of all, what's EPRI, and then paraphrasing those two questions. What are the energy storage opportunities, and also what are the challenges, and how EPRI is approaching addressing those challenges. So first of all, EPRI is a collaborative, nonprofit research and development organization. We're primarily funded by, we serve the electric power industry. We're primarily funded by electric utilities, and we have a collaborative model where utilities join our programs and fund programs. In my case, the energy storage program, and we solve the problems together. So the energy storage program at EPRI is focused on grid-connected energy storage technology and solutions. We look at all types of applications, from centralized pump hydro facilities down to customer side of the meter energy storage. And we look at technologies, flow batteries, lithium, lead acid. But our focus is primarily on technologies that we think have a commercialization path in the next 5 years. So moving on to the second agenda item, there are really 3 external drivers and 1 internal driver of storage that makes it look like it's going to be more important in the future than it is today. First one has been discussed. Intermittent renewables, wind and solar introduce new ramping and time of production problems that have not been part of the grid, or not part of the traditional grid up to this point. Another driver is that there is more importance for electronics now, and the value of reliability is increasing for short term. So storage can help mitigate outages if present toward the edge of the grid, near to the loads. And then also the sustainability, I guess, of the current solutions that are being used to address problems with grid support. So generally, utilities are used to using wires and poles anytime they need to look at their changing grid. But one of my colleagues, Bob Entrikin, said that right-of-way is a limited resource. So you're not always able, when you need to use when you need to build wires and poles, you want to do it in a measured approach. You don't want to be doing that haphazardly and stupidly. And then finally, there's an internal driver, which is that storage is becoming more prevalent in other industries, which is driving costs down. So for example, take one example, lithium-ion batteries are now commercial in all sorts of power electronics, and they are now becoming the basis for electric transportation. And that's driving a huge scale in that industry, and it's driving down the cost of lithium-ion batteries. So moving on to the third agenda item, what are the barriers and challenges? I have 3 here. First of all, utilities aren't sure what they want to do with storage. So, I mean, there's all these great benefits that people have identified, but we're not sure which ones we want to use it for, because sometimes the ones that we want to use it for are not the high-value ones. So at EPRI, we try to simulate how what are the grid impacts of storage under different scenarios so we can understand where those are. The second issue is that a lot of vendors who are working in energy storage right now have early stage technologies and they're not providing a whole product. They have, for example, if you're a battery company and you're working on building a module that's a kilowatt hour to demonstrate, if it doesn't have a power conditioning system and balance of plant, it's not of interest to the utilities to test that because they don't really understand how it's going to work on their system. So at EPRI we work on functional requirements with a collaborative utilities, and in some cases we also work on technical specifications to try to understand the utility needs as a whole. And then finally, safe, reliable, cost-effective energy storage. So utilities are conservative organizations by design. They have a regulated profit, so they don't have any incentive to take risks on new technology that does not have a track record. So every we're working on building track records for new energy storage technology by doing lab testing and demonstration, and also trying to understand, as Josh was talking about, how you can stack benefits and how they might be able to be monetized in the real world, so you can do a cost-benefit analysis that makes sense. And there's this issue, and I won't want to get into this, I'm sure we'll talk about it pretty soon, but basically some of these benefits are traditionally rate-based benefits where utilities go to their Public Utility Commission and ask for recovery, and other ones are essentially market participation. So right now you're not allowed to get your asset rate-based and then also participate in the market. So there needs to be some clarity going forward to make those investments. So I guess I'll end it there. Thank you.